Hey there maths fans, we're looking at adding fractions in this tutorial. So adding fractions, we're going to start off with what we call like fractions. These two fractions here are like fractions, they are alike. Now we say they're alike because they have the same denominator, the denominator being the bottom part of the fractions. So because they have the same denominator, adding them is actually really easy. If we imagine this is a whole thing, and if I split it into 5 equal parts, or attempt to, let's imagine those are equal parts. If I've got 2/5, colour in 1 2/5, and I add one more fifth, I just add one more like that, I've got 3/5. They don't change into tenths, nothing happens to the denominators, I end up with 3/5. So when we have like fractions, adding them is really easy. And the same with subtraction. So when the denominators are the same, you just add the numerators. So when the bottoms of the fraction are the same, you just add the numerators when we're adding fractions. Now, I'll just give you a couple more examples just to make it clear what I'm saying. So if I've got 7/20 and I add 4/20, I get, just add the tops. 7 add 4 is 11/20. Same with subtraction. If I had 9/10 and I subtract 2/10, I've got 7/10. They don't change the denominator at all, they stay the same. So that's easy adding and subtracting of fractions. When we've got the same denominator, it's an easy task. Problem is, we don't always have the same denominator. So here we have an example where we've got fifths and tenths. So we don't have the same denominator. What we need to do is use equivalent fractions to make them both have the same denominator. So what I'm looking at is multiplying the top and the bottom of one of these fractions, maybe both of these fractions, to give them the same denominator. Well, I know that 5 is a factor of 10, so if I multiply this by 2 and make 10 on the bottom, 2/5 is the same as, if I times by 2 on the top as well, I get 4/10. Now 2/5 is equivalent to 4/10. So I haven't changed that fraction, I've just written it with a different denominator. Now if I do that plus 3/10, my job is nice and easy. I add the tops and I get 7/10. So the key thing here is to look at the denominators, the 5 and the 10, and try and manipulate them. In this case, I just multiplied the left-hand fraction by 2 on the top and the bottom. Whatever you do to the bottom, you must do the same to the top, otherwise you're changing the fraction. But we can multiply by any number we want. Let's have a look at another example then. So we've got 2/3 add 1/10. Now here, 3 and 10, neither is a factor of the other one, so we need to find a common multiple. I'm going to have to change both of these fractions so they have the same denominator using a common multiple. So I look at the denominators, the 3 and the 10. What do they both go into? So I could write out the 3 times table, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, and then write out the 10 times table, 10, 20, 30. I'm not going to go any further because I've just spotted 30 is in both times tables. So you find a number that both of these go into, a common multiple, and then we're going to make them both have that as their denominator. So I'm going to have 2 fractions equivalent to 2/3 and 1/10 that have a denominator of 30. So let's just tidy this up a bit. So I'm going to go for, what do I times 3 by to get 30? I times that by 10. So I do the same to the top. 2 times 10 is 20. 2/3 is the same as 20 over 30. I'm happy with that. I'm dealing with the same fraction. On this side, to get the 30 on the bottom, on the denominator, I'm timesing by 3. And whatever you do to the bottom, you do the same to the top, times it by 3, and I get 3 over 30. So 2 over 3, add 1 over 10, I rewrite it with the same denominator, and then I just add the tops, add the numerators. 20 plus 3, 23, and the denominator stays the same. So that's the key to unlocking these questions, is find a common multiple for the denominators. I'll leave that example up there, and then I'll do another example, this time with subtraction. So let's go for 2/3 minus, let's go for 2/5. Here, I need a common multiple of 3 and 5. Well, I happen to know that 15 is in both those times tables. So I'm going to make both of these fractions with a denominator of 15. Here, I've times by 5, so I do the same to the top. 2 times 5 is 10. Here, I've times by 3, so I do the same to the top. 2 times 3 is 6. Now this one I'm subtracting. You'll notice all of the steps were exactly the same until now. Instead of adding the tops, I take them away. 10 minus 6 is 4. And there's our answer. 15 on the bottom stays the same. Okay, let's have a look at one or two more examples. Here we have a half and 3/4. So again, look at the denominators, and we're going to make both of these have the same. Well, I know that 2 is a factor of 4, so I could actually make these both over 4. I don't need to change the one on the right. So I've got 3/4 there. This one I've multiplied by 2. So I get 2/4 plus 3/4 is 5 over 4. Now that's fine. However, this is an improper fraction. The top, the numerator, is bigger than the bottom. So you might be asked to write that as a mixed number, in which case, how many 4s in 5? I get 1 whole 1 and a quarter left over. So if you have one where you end up with a mixed number, no problem. Same techniques all apply. Okay, one more here. Give this one a go. This has got a mixed number as an answer. So maybe pause the video, see if you can do this on your own, and then I'll go through the answer. And I'm going to go through the answer now. Okay, we've got that 3 and 5 again, and if we remember, 15 is a common multiple of 3 and 5. This one I've times by 5, so I'll do the same to the top. 2 times 5 is 10. This one I've times by 3. 3 times 3 is 9. Add those together, and I get 19 over 15. And 15's into 19 is 1, remainder 4. So if I wanted that as a mixed number, the answer is 1 and 4 over 15. So there you go, adding fractions. The key thing is look at the denominators, find a common multiple, then use equivalent fractions. So whatever you multiply the bottom by, do the same to the top, and then you're there. Okay.